talking about to infinity and beyond today.
Yeah, but with like some spook jazz.
Like, you got a friend in me? Mm-hmm. I should do that. That'd be funny. Yeah, maybe we'll make that happen. All right, so we're talking infinite geometric series. So, there's going to be a lot of, at the start of today, there's going to be a lot of abstract stuff, is probably the best way of saying it, because we have to determine what's all happening. Okay? So on the board I have two different series. Okay? What can you tell me about those series? What do you got?
They go on forever.
They do go on forever. They go on to
Infinity.
infinity. Good thing, because we're talking about infinite series today, right? Yeah. Infinity numbers. Yes. Okay. So, what about the first one? What can you tell me about it? Or the second one? What can you tell me about it? What do we got? First one or second? First one, you're multiplying by a third every time? Yeah. Okay. All right, I would agree. Does everybody else agree with that? Multiplying by a third. Okay. Second one? What do you mean increasing by 2? Multiplying by 2.
Yeah.
Yes, multiplying by 2. Increasing by 2, just so you know, would mean like arithmetic. You with me? Okay. Multiplying both every term by 2 to get the next term. Everybody agree with that? Now, one of the things that I didn't have you do yet is graphing a sequence or graphing a series. Okay? So I'm going to show you what a graph would look like right now. Okay? So those are the graphs of those of series 1 and series 2. Okay? I just graphed them on a graphing calculator. I just made a spreadsheet with them, plopped them in there, okay, and then did the graph of them. Okay? So, what can you tell me about those series now by looking at their graphs?
Series 1 is an exponential decrease or decay, and the series 2 is an exponential increase.
Okay? Do we agree with that? That the left series, series 1, is an exponential decay, okay, and series 2 is an exponential growth. Yes? Okay. I would agree they look exactly like an exponential decay and an exponential growth. Okay? The left series, though, because we're talking about sequences and series, we don't call it decay or growth. We call it converging. Okay? So the left series is converging So if the left series is converging, what's the right series then? Diverging. Okay. Now the nice thing with infinite geometric series is that if your series is diverging, you can't find the sum because the next term is bigger. It's always bigger, right? If I found the sum just of those first 5 terms, so that's 14, that's 30, that's 62, right? Well, the next term is going to be 64, which is going to double my sum, right? The next term would be 128, which would double every time. That sum is almost doubling. Okay? Whereas on this one, on the left one, a converging infinite series, okay, that next term is getting closer and closer to what? It's getting closer and closer to 0. So if I go a couple of more terms out there, am I really adding any value to my sum? No, I'm not, because I'm basically adding 0. You know, if you, I don't, somebody got a calculator out? What is 2 divided by 81?
0.024691.
So 0.024, right? Okay. So then the next one would be 0.004. And the next one after that would be 0.001. So we're really not adding a lot to that sum. Okay? So this R value here we said was 1/3. And this R value we said was 2. Okay. What about if R is negative? Series 1, Series 2. What can you tell me about those now, other than the fact that R is negative? Well, can you tell me about Series 1 or Series 2?
I believe Series 1 is still going to be an exponential increase. And then Series 2 is going to be a decrease. It's my guess.
It's your guess.
My guess.
Okay. But do we use those terminologies in sequences and series?
No, it's converging.
Okay, so would you like to restate your statement?
Yeah, Series 1 would be diverging, and then Series 2 would be converging.
Okay, do we agree with that? Series 1 is diverging, Series 2 is converging. Okay? Would it help to see the graphs? See why we can't say exponential growth now? Okay? Because it doesn't follow that smooth curve, because each term is flipping, flopping between positive and negative. Okay? But as you notice here on Series 1, so if I start with this term right there, then my next term is a little farther away from 0. Then my next term is a little farther away from 0. Then my next term is even farther away from 0, and then even farther away from 0, and then even farther away, and then even farther away, and then, you know what I mean, how it's going to converge, or can we diverge? It's getting farther and farther away from 0. Okay? Whereas in Series 2, it's getting closer. To 0. Okay. So these two again, on this one, where R, what's the R value in Series 1? -2. And in Series 2? -0.5. What's my other possible value of R? We've had positive, we've had negative. What's my other possible value? Because it's not 0, remember. We talked about that a couple weeks ago. But we can't have a value of 0. What's my other possible value? Positive numbers, negative numbers, or what if R is 1? Then what happens? It doesn't diverge or it doesn't converge, right? It just stays constant. Okay. Can I have a sum of this one? Why not? Because what happens if I add that next term? What am I going to add? I'm going to add 2. Okay, so then we would find the sum. But then if I go to the next term, add 2 more, and so on and so forth. So in this case, there is no sum either. So let's put all, what are there, 5 of those together. Now, which ones have sums, which ones don't have sums? Whoa, tap the brakes, double tapped it. For what R values do infinite sums exist?
Negative fraction. Wait, no, my bad.
Greater than 1? Okay, so our first guess was greater than 1. So that would be like series 2, right? Series 2? I said which ones have sums.
Oh, yeah, so they're negative and if they are fractions. And if they were fractions. Less than 1. And negative.
So our new guess now is if it has sums, it's less than 1 and it's negative. And or negative. Okay. What about negative 2? Negative 2 is less than 1 and or negative.
But greater than negative.
Okay, so can you simplify that even more?
A number that is in between 1 and negative 1.
So our R value has to be in between negative 1 and positive 1, correct? Can it be equal to positive 1? No. Can it be equal to negative 1? No, because that wouldn't converge either. Okay? So our R value has to be in between there. Anywhere else, and what? What about the sum? There is no sum. Okay? Anything else and the sum does not exist. Okay? So when you're looking at a problem now with going to infinity, there's 2 ways to know that your problem is going to an infinite sum. One way is it's in sigma notation, and there is a big old infinity on the top. That's one way to determine that your sum is going to infinity. What's the other way? The dot, dot, dot. Yep. So you would have something along the lines of plus some number plus... Oops, I should put that in blue. Then I stay consistent. Yeah. At the end of your series, it goes plus dot, dot, dot. Okay? Then, so that's your first look. Is it an infinite? Because if it's not infinite, then we go back to last week and those formulas. Okay? But if it is infinite, then we have a new formula. And this new formula is phenomenal because it's just that. It simply is the infinite sum is equal to the first term divided by 1 minus r. Notice how it's not s sub n. Because there is no number of terms, because the number of terms is infinity. Okay? Ready to try one? First check is infinite sum, non-infinite sum. Is this an infinite sum?
Yes.
Why?
Got infinity is
Okay. Because there's an infinity sign up there at the top of my sigma. So that tells me that it is an infinite sum. Okay? Second check is, what is my R value? That's a bad question mark. What is my R value of this of this series? Almost said this system.
1/4.
It's 1/4, right? So my R value is 1/4. Is that good or is that bad?
Good.
Why is that good?
Because it's in between -1 and 1.
So that means that there is a sum. A sum exists. Now, as you get going on these, those two first things that I have you do will take all of 3 seconds. Okay? So don't freak out that I'm making you do all this extra work. Okay? So now that we know that it's an infinite sum and that sum exists, now we can use our S equals our first term divided by 1 minus R. In order to use this, what are the two things that I need to find?
2, 1.
I need to find my first term. Okay? What is my first term? We got Jacob? 3. How'd you come up with 3? I put 1 in for n, so that's going to be 3 times 1/4 to the 1 minus 1 power. 1 minus 1 is 0. Anything to the 0 power is 1 times 3 is 3. So my first term is 3. We already found the R value, correct? Okay. So that means then that my sum here is 3 divided by 1 minus 1/4. What is 1 minus 1/4? That's 3/4. Dividing fractions, what do I do? Multiply by the reciprocal. So that is 3 times 4/3. Right? Can I put the 3 over 1? No? So what is that? You get what I'm saying? 4? Think about it this way. What's the first term? 3, right? So the first term is worth 3. Every other term to infinity is worth a total of 1. Okay? Kind of a little weird. That 3/4 of your sum is in the first term.
Would it always be like that?
Depends on what your R value is. Because if your R value is closer to 1, then your sum will be bigger. Because you're not losing as much every term. If your R value is closer to 0, it's not going to be very much more than your first term. Okay. Try that one. Infinite, not infinite. Infinite, right? Okay, because there's an infinity sign top my sigma. Question 2. R value. -1/2. Does that fall in my applicable R value range? Yes? Okay. So that means that I have a sum. So the sum is going to be my first term divided by 1 minus R. What is my first term? What is, and we said R was -1/2. Okay. 1 minus -1/2. What we got? 3 halves.
Oh, yeah.
I don't do mixed numbers. Remember? Yep. Flip and multiply, right? Does that make sense?
Yes.
Why?
Because it's flipping over the 0 or x-axis. So you're going to be adding like some positive, and you're going to be taking some away. So your like net total is less than your starting first point.
But and that's okay?
Yeah.
Because what's freaky to this one about me is my first term was 1, and we got a sum that's less than 1. So, but that worked because what you said, each term flip-flops positive and negative. Yeah. All right. That works for me. Try that one. Infinite, not infinite. Why? Dot, dot, dot at the end. Okay? Plus dot, dot, dot. So that means it's infinite. This also right here signifies we're going to infinity. Okay? R value. How do we find an R value when it's not in sigma notation? Any term divided by the term right before it, right? Okay. So 3 halves divided by 1 should be the same as 9/4 divided by 3 halves. Should be the same as 27/8 divided by 9/4. All of those are equal to what? 3 halves. Is that good or is that bad? Why is it bad? So what's my sum? No. Oops, wrong color. So we say no sum. Or sum does not exist. Do not say infinity.
Why?
Because what is infinity?
It goes on forever.
Right, but what is infinity?
It's abstract.
Plus 1, right? Plus 1, right?
Right.
Well,
Right.
can't say infinity. Right? No sum or sum does not exist. Yep. Sweet.